Hello students. In this lecture, this is fourth lecture for probability, and we are going to discuss some important concepts here. The first concept here is complement of an event. Clear? If E is an event, then the complement of E is denoted by E bar. Just remember, we put a bar on it. Clear? And it is the event that contains every outcome. So every outcome for the experiment that do not belong to E. That means, look, if this is the sample space, clear, and this is event E, then this remaining portion is E bar. This portion is complement, E bar. Clear? This I explained you in form of a set. Clear? So, and here is E plus E bar is equal to this. Understand? So, one more thing I want to tell you, that this is E plus E bar. Similarly, probability of E plus probability of E bar is always equal to 1. This thing you need to remember. Probability of E occur plus probability E does not occur is 1. Means if something is happening, then we can calculate with the probability that does not happening. Clear? And you can calculate probability of E is equal to 1 minus probability of E bar, or you can calculate probability of E bar is equal to 1 minus probability of E. So what does this mean? This means is, yes, in the last lectures I explained that there are 10% of chances that there will be rain. So 10% means 0.10 probability. Clear? So 10% chances means 90% are the chances that there will not be rain. If 10% are chances for rain, so 90% are chances for not the rain, because 100 minus 10 is equal to 90. This is how to use the concept of complement. And I want to tell you that let us consider the rolling of a die. Clear? So sample space will be how much? 1, 2, 3, 4, 5, 6. Clear? Now you consider E is an event. Let E is the event of getting odd numbers. Then what is the value of E? The value of E is getting odd number 1, 3, 5. Clear? So this is about the E. And if we want to write about E bar, So E bar is the event for not getting. Here it was getting odd numbers. So here it is not getting odd numbers because it is complement. Not getting odd numbers. Clear? So what will be the value of E bar? The value of E bar will be remaining. Here 1 we have chosen, 2 we have not taken. So 2, 3 we have taken, 4 not taken. And 5 we have taken here, 6 not taken. So this is clear. So if you calculate here probability of E is, it is 1, 2, 3. Divide by 1, 2, 3, 4, 5, 6. And if you make lowest, it is 1 upon 2. Similarly, if you want to calculate probability of E bar, how much it is? 1, 2, 3. Same, 3 upon 6. It is 1 upon 2. So you can prove this value. And this is how much? 1 upon 2 plus 1 upon 2. It is 2 LCM. 1 plus 1 is 2. 2 upon 2, and that is 1. So probability of E and the probability of complement is 1. Understand? One more question we can take here with the if the probability that a flight from Muscat International Airport is delayed is 0.14. What is the probability that the flight from Muscat International Airport is delayed? It is 0.14. Clear? Then the probability that flight will not be delayed, will not be delayed is how much? It will be 1 minus 0.14. And 1 minus 0.14 is how much? It is 0.86. So the probability that the flight is delayed is 0.14. Will not be delayed means, what is the meaning of will not be delayed? Will be correct time. Clear? Will be right time is 0.86. So using complement, you can calculate anything. Clear? If something is not correct, clear, and the correct, so the sum of these two, correct and not correct, will be equal to 1. This is the use of complement. Okay. Now the second definition we are going to study is conditional probability. Conditional probability. What is conditional probability? This is a very important topic. Suppose conditional will be on two bases. There will be not one event, there will be two events. Let A and B are two events for an experiment. For an experiment. Now here is conditional probability means, and you need to consider, and suppose that event B has already occurred. Clear? It is, you can just imagine what happened if the 9 a.m. flight to Dubai is correct time. Clear? Next flight is 10. So we can expect the next 10 a.m. flight will be right time. But by chance, because of some issues, the flight that was scheduled at 9 in the morning to Dubai was delayed by 30 minutes. So now the flight at 10, there are chances that it will also be delayed. Clear? So it is conditional. If previous flight was on right time and nothing serious happened, so next flight will definitely be on right time. Clear? But if previous flight is delayed, so next flight, there are chances that it will be delayed. So whenever some problem happened, so it impact the future. Clear? So same is here. If B event has already occurred, then there are, so we need to calculate the probability. What is this? Then we can recalculate the probability of A based on this information. Based on this information. Clear? And based on this information, we can recalculate the probability of A. And how we calculate? The conditional probability of A. This is called conditional probability. Conditional probability of A, given that B has already occurred, is denoted by probability of A, and vertical line, this is known as probability of A given B. This is, and the value of this is P A given B is P A intersection B upon PB. And similarly, we can calculate the other also, probability of B given A. It is what it is, probability of A intersection B upon PA. Clear? So this is how the conditional probability we define. Now we will take one question based on the conditional probability. More questions I will bring you in the last lecture when we will solve mixture of questions. So this is a very good example. There was a bag, and that bag contains how many white balls? There are white balls 8 in this bag. How many red balls are there? Red balls are 6. And the green balls is 4. This is question number 4.3.6 on page 94. This is on page 94. You can read in your book. So there was a bag, and this bag contains 8 white ball, 6 red ball, and 4 green balls. How many total balls? It is 18 total balls. Clear? White balls denoted by W, red balls denoted by red, and green balls denoted by green. So if, what is the question? Question is, now given that Given that we draw two balls from the box without replacement. There are two things, without replacement and with replacement. With replacement means you draw one ball from the bag and then you are putting the ball back to the bag. Clear? To the box. This is replacement. Without replacement means you draw the ball and you are not returning ball to the box. Clear? So if you draw one ball, so the sample space will be 18. But if you are drawing a second ball without replacement condition, so in second case the probability means sample space will be 17 because one ball you have already drawn. So this is the condition for without replacement. So one ball will be less because we need to draw two balls. So whenever you draw first ball, the sample space will be 18. But in case of second ball, when you will draw, sample space will be 17. This is the condition of without replacement. Now you need to draw two balls. And the first ball, what is the condition? First ball, it should be a white ball. You need to draw the first ball white. And second ball you need to draw is the white ball. So you need to find the probability of drawing two balls without replacement, and first ball should be white and second ball should be white too. Understand? Now we are going to find some probability. Please listen the question because it is a conditional probability question. If they ask you what is the probability of PW1, probability of first white ball. Clear? PW1. What is the probability? PW1 is means NW total white balls upon a total sample space. What is how many white balls here? 8. What is the sample space? Is 18. This is how we calculate the first ball. Now if you are drawing the second ball, so there are various conditions. Now, first, because they have not given, we are just calculating all possibilities. It is W2 given W1. What is that? We are drawing second white ball. Probability, listen carefully, probability of getting second white ball given that first ball was white, means first ball was white and first ball we have already drawn. If first ball we have already drawn, so 18 minus 1, it is 17. Because first ball also white, so white one ball already draw. So what is the answer? Answer is 7. Here is 17 and here is 7. This is the answer. Probability of W2 means you are calculating W. Given that first ball already you have drawn. If first ball is drawn, so 1 less. Here will be 1 less. Here will be 1 less. Why? Because it is without replacement. You did not put the ball back to the box. Okay, this is 1. Now, probability of W2 given W1 complement. What is the meaning of this? The meaning of this is probability of getting what? W2. W2 means white ball. Getting white ball given. What is given? That first ball W bar, W1 bar. W1 is a white ball and W1 bar means not a white ball. First ball was not a white ball. Clear? So, one ball already drawn, that was not white. That is another condition. Because one ball already drawn, so denominator will be 17. But because the first ball was not white, so for the second one, all 8 balls are available. So the answer is 8 upon 17. This is very important part. Now, one more part is there in this question. As per your book, P, it is W2 bar given W1. What did this mean? W2 bar, probability of getting. What was the value of meaning of W2? Meaning of W2 was it is a white ball. W2 bar means what? W2 bar means probability of getting not a white ball. Not a white ball. And what is given? Given that W1. W1 means white ball. Given that the first ball was white. So, because first ball has already drawn, so denominator will be 17. But we are calculating W2 bar. W2 bar means that the probability of getting not a white ball, and not a white ball means either it will be red ball or a green ball. 6 plus 4. 6 plus 4 is 10. So the answer is 10 upon 17. Clear? More question I will bring on this conditional probability in the last lecture when we will solve the exercise problems. Here only one question is given in your book. So that's all. Okay. So the next topic we are going to study here is independent and dependent event. Dependent events. Okay. Independent and dependent events. What is this? Same. Let A and B are two events such that they are not depending on each other. Clear? Then please remember that probability of A intersection B. A intersection B means probability of A intersection means and both A and B will be equal to probability of A into probability of B. This is the condition. Clear? And in case of conditional, if you want to calculate the value of if you want to calculate the value of P A given B as per your book, I explained you it is equal to P A intersection B upon P B, and that is equal to PA. Independent means intersection is equal to the product PB. Now this cancel, so it is equal to PA. This is one condition, and another condition you can take is P A given B, you can take B given A. So it is P A intersection B give upon P A. Because the events are independent, so P A dot P B upon P A cancel, so it is equal to P B. Clear? So two events will be independent if their intersection is equal to the product. This is very important condition. This condition you need to remember for two independent events. Like now I want to tell you one example. Example is if you are throwing a coin and if you are throwing a die, both are independent. Clear? Because if you are rolling a die or flipping a coin, they are not impacting any other because both are independent. Clear? For example, rolling a die and flipping a coin together are independent events as they do not impact the probability of each other. This is, and another thing you can think about it, that if you are talking about dependent, so two events are called dependent. Two events are called dependent only if one's occurrence affects the likelihood of the other. Clear? Then the events are dependent events. For example, you can consider in this question, not this question, we were solving this question. Clear? If here is without replacement, if you are considering it with replacement, then two events, the first or second, they are not impacting each other. If it is with replacement, without replacement means if we are drawing the first ball as white, so it is directly impacting the output of the second. Clear? So first and second both are dependent here. Why dependent? Because it is without replacement. But you consider in this question as with replacement, so then the event W1 and W2 will be independent events. Understand? So this is about the what we call it dependent and independent event. And one more thing I want to tell you, in two things you learn, this is called union and this is called intersection. Union is used for or, intersection is used for and. So if I'm talking about two events A and B, if I'm writing two events A and B, that means I'm asking about the probability of A intersection B. And if I'm writing two events A or B, then I'm asking the probability of A union B. So my dear friends, in the next lecture, we are going to discuss these two important concepts of the probability. One is the intersection, another is the union. Thank you very much.